Hello and welcome to lesson 3.7 on graphing cubic functions. We are going to be going a little bit out of order. And I did want to quickly mention in my last video, I was saying a lot of, hey, it should be the word and. They're kind of used interchangeably. So if we use or, kind of like how we did in module 1, to talk about our two answers for positive, negative, increasing, or decreasing, that is okay. I think on big ideas it has and then on Delta Math it has or, so wanted to clarify that. All right, jumping into lesson 3.7, we're going to talk about roots, multiplicities, y-intercepts of cubic functions in factored form, and then we're going to sketch a graph of a cubic in factored form based on its key features. So all of this would be on a non-calculator part of a test. So think back to module 1 when we studied transformations. What do each of these graphs look like? So if it is happening inside the parentheses, I know it is moving to the left or to the right. It's the opposite of what I think. So a -3 is actually going to shift this graph to the right 3. Now the squared means it's a quadratic. And so we know quadratics look like U's. So if I would go to the right 1, 2, 3, this will be a quadratic opening up. Now, a key thing today, if your exponent is an even, it is essentially going to bounce off of the x-axis, kind of like a quadratic does right here. But our lesson is on cubics. So let's talk about what this cubed is actually going to do on a graph. I know +3 is going to shift it to the left 3. So it's going to start 1, 2, 3, somewhere over here. Now a cubic function, since the exponent is an odd, it's actually going to cross through the x-axis. So we know a cubic looks kind of something like this, where it is crossing through the x-axis. So if the exponent is odd, it kind of looks like a linear-ish function, a little bit curved right here, leveling out. Okay? So that is the biggest thing. If your exponent is even, it's going to bounce off the x-axis and treat like a quadratic. If your exponent is an odd, it's going to cross through the x-axis. So those are the two big key concepts for today. If you remember, factored form is going to give us our zeros, which are our x-intercepts. The exponent attached to those factors will tell you if the graph is going to cross or bounce. And then knowing this can help us predict what a polynomial function will look like without the aid of a graphing calculator. So let's get this started. So our first function, draw and sketch the following polynomial. Y equals x plus 2, x minus 3 squared. So this exponent of a 2 essentially means I have 2 of my x minus 3's. So I could expand this problem into x plus 2 times x minus 3 times x minus 3. Okay. Part A, these questions are going to walk us through how to graph it. So find the first term and leading coefficient. So the first term is an x and an x and an x. So my first term would be x cubed. And so that's what makes this a cubic function. The leading coefficient, there's no number in front of the x, which is essentially the number 1. So my leading coefficient would be a 1. Now, from the last lesson, I know that end behavior is based solely off the first term and the leading coefficient. So these are all positives. So I am not going to actually write the end behavior, but I know a positive graph is going to be going up. And so all I care about is your start and your beginning arrow. So it's going to start going down and end going up. So for end behavior, that's kind of all, my goodness, you really need to know because it is positive. The next part, I need to figure out my zeros and if there are any multiplicities. So the first 0 would be x plus 2. So it would cross the x-axis opposite at x equals a negative 2. My other x-intercepts would be a positive 3 Now, this squared means that I have a multiplicity. So it has a multiplicity of a 2 because there are 2 of them. So since this x minus 2 does not have an exponent, it's essentially a 1. Now 1 is an odd number, so it is going to cross through the x-axis at a negative 2. This multiplicity of a 2 means it's going to act like a quadratic, so it's going to bounce off the x-axis at a 3. And that will make a little bit more sense in a second. The last thing you need to do is calculate the y-intercept. So we know from the last module, module 2, to calculate our y-intercept, we're going to plug in 0. So I would take 0 where x is and simplify. So 0 plus 2 is 2. 0 minus 3 is negative 3. Anything squared is going to be a positive number, so negative 3 squared is going to be 9. And then I would multiply those two numbers. So 9 times 2 is 18. So I know my y-intercept is at a 0, 18. So I'm going to take all this information and draw a rough sketch of a graph. So let's start with our x-intercepts. I'm going to go boom, boom, negative 2 is one of my x-intercepts, and then a positive 3, boom, boom, boom. Last but not least, my y-intercept would be a 0, positive 18, so roughly somewhere up here at a 18 is going to be our y-intercept. Now, it doesn't have to be pretty, we're doing rough sketch. All right, the fun part, we're going to sketch the graph. So important thing, my arrow has to start going down, so my pencil or my pen is going to start down here at the bottom left of my graph, and it will end going up. The first x-intercept I'm going to hit would be a negative 2. So start down here and approach this negative 2. It's going to cross through at a negative 2, so I'm going to make sure to cross through the x-axis. The next thing I'm going to hit is the y-intercept. So I'm going to go all the way up here to my y-intercept, touch it. Now I'm going to come back down to my other x-intercept of the 3. Now when I hit the 3, I don't need to cross through it. I actually need to bounce off of it because of the squared. And there's my graph. So we can add our arrows. And that will be a rough sketch of our cubic function. So start down low because the end behavior was positive. It's going to cross through at a negative 2, go up, hit the y-intercept, come back down, and then bounce off and kind of act like a quadratic because of this squared. Awesome, awesome. Now again, if you wanted to check your work, you could obviously graph it. Desmos is a great way to check your work also. So if I went to Desmos and typed in y equals x plus 2 x minus 3 squared, I can kind of see, if I zoom out, that's the prettier of what your graph would look like. So it would be crossing at a negative 2, crossing at a positive 3, crossing the y-intercept, going boop, boop, boop. All right, let's try another one. Number 2, draw and sketch the following polynomial. So we've got an x in the front with a no parenthesis, which is going to add some level of difficulty. X minus 5 and x plus 2. So first term is to predict the leading coefficient. So my leading coefficient is a negative 2, a 1, and a 1. And so 1 times negative 2 would be negative 2. And then I've got 3 x's, so x cubed. My leading coefficient, the number in front, would be a negative 2. Now that leading coefficient is going to tell me which way my graph is starting and ending. So if it is negative, it's going to start up high and end down low. So my arrow will start up high, and then on the right side it will end down low because it is negative. Step 3 would be to identify any zeros and if there are any multiplicities. This first one is a little tricky because there's no parentheses. So to find a 0, I can take negative 2x and set it equal to 0. And I would solve this problem by dividing by -2 on both sides. Ooh, it's so hard to write on the computer. And anything, 0 divided by anything is going to be a 0. So one of your x-intercepts is 0. So essentially, if there is no parentheses, it's going to be a 0. If I've got x minus 5, that would change to a positive 5, and then x plus 2 would change to a -2. So those are our 3 x-intercepts. Now I need to figure out if there are any multiplicities. There are no exponents, so I don't have a multiplicity, so they're going to cross at every single x-intercept. So we're not going to be bouncing off anywhere. On part D, we're going to find the y-intercept. Again, plug in 0. You're going to have to plug in 0 3 times. So I would have -2 times 0, 0 minus 5, and then 0 plus 2. And we could do some mental math. So -2 times 0 is 0. 0 times literally anything is going to be 0. And so our answer is 0. So our origin is our y-intercept. And so now we're going to go ahead and take all this information and sketch a graph. So I've got crossing at a 0. Somewhere over here would be a positive 5. And then somewhere over here would be a -2. So it does not have to be pretty. All right, so my graph is going to start going up. So I'm going to start with my pencil up here on the top left-hand corner. The first number I'm going to approach is a -2, and I want to make sure to cross through it. So start up high, go down here, cross through a -2. The next number would be a 0. So I'm going to head back to 0. I'm going to cross through it again. The next number I'm approaching is 5. So I'm going to go back down to 5, and I'm going to cross through again. Ta-da! And here is our lovely cubic function. Starting up high, crossing through -2. If we want to put a 0, crossing through 0, and then crossing through 5. And again, if you wanted to check your answer in Desmos, it would give you a way prettier graph than this. Okay? Alrighty. Thank you for watching part 1. You can head over to watch part 2 now of how to finish graphing these.